He first introduced Eran Shir. Eran, are you here? Eran? We're hoping Eran's here. There we go.
I am.
Eran is the co-founder and CEO of Nexar, an artificial intelligence dash cam application that seeks to rid the world of car crashes by becoming what he describes as the road's air traffic controller. He's a serial entrepreneur and a leading force in applying AI techniques into automotive applications. Eran founded Nexar after stints at Aleph and Tel Aviv-based venture capital firm and Yahoo, where he was head of the Creative Innovation Center. Eran?
Thank you, sir.
All right.
Hi, everyone. Really excited to be here all the way from Tel Aviv. I'm going to talk to you about what we do at Nexar, which is not building a self-driving car. I guess going to give you somewhat of a different perspective on what can be done right now. What we have built Nexar for is to really get rid of car collision at scale. People have talked about it before me. And the real sort of tension that exists between the current situation and what we all are sorting for, what we all are looking for, I think can be captured very well with these two graphs. You know, this is the interest in autonomous vehicles captured by Google since 2014. You see an exponential growth, and all of us are sort of a testament of that. There's another major growth that happened during that period, which is the number of fatal crashes and fatalities in general, both in the US and in the world in general. And we, just like we heard before, we're now back to 2007 numbers with all of the technology that's now being deployed in cars. And that is really frustrating. One of the main challenges we saw is that whatever sensors you put on a car, it is confined by your line of sight. And so we were looking at vehicle-to-vehicle networking as a way to increase that, go beyond line of sight. And this has been something that has been around for the better part of the last 2 decades. Right? It's been a really exciting idea, really exciting concept, but in practice it really failed. You know, people have tried this, to push this through regulation. People have tried to create all kinds of standards around it. In practice, nothing has been commercialized in any meaningful way. And the main reason for that, it's sort of a chicken and egg problem, the main reason for that is that you need to have massive density in order to make it happen. Right? You need like 20, 30, 40% penetration in order to make it happen. Now, what we've done, we decided to kind of change the game a bit. What we've done is we've merged recent advances in AI, in scene understanding, with vehicle-to-vehicle real-time networking over cellular to really understand at scale the environment, to sense it, and then to share that information in real time with neighboring vehicles. So the density required is much, much lower. And we've deployed that across different channels, from apps running on smartphones through dashcam apps all the way to infotainment systems in cars to get to density. We deployed that in multiple cities, in select cities, started in November 2016, and now a bit more than a year after. In New York, for example, we see over 5 million V2V events every week. Okay? And we're on track to get to 100 million events every week by the end of this year. Okay? And that means that you can do way, way more. You can see much more. We collect over 1 million hours of video, but more importantly than that, over 1 million dangerous events. You know, the craziest thing that you can even imagine are in our database. If someone is interested to open up a TV channel, we have enough for that. You can see, you know, all of the craziness, and before me, you know, you've seen some of these examples. Really, we have ample of them. You see people distracted, you see collisions, you see near misses, you see trucks running red light. Really, anything that you can imagine, we probably got it on tape somewhere. And all of that allows us to really feed our AI systems, our deep learning models, in order to understand better and in order to squeeze all of this intelligence into a form factor that is democratic, that everyone can use. And we provide today what we call a holistic ADAS, an ADAS like forward collision warning that is based on cameras and perception, and is good for the 1 to 3 second range, the line of sight range, but also ADAS that is based on the network, where if you're going on the 101 and 3 cars ahead of you, someone is doing a hard brake, within 100 milliseconds, you get a warning. This is not like a vision. This exists and running, and we save lives with it. Okay? And you can think of additional use cases, like, for example, intersection movement assist. That is actually my favorite. It's like warning you about a car coming behind the corner. And you can actually clock it and see it emerge just when it's supposed to be, and many others. But there is another layer to this, okay? So the first layer is we want to prevent collisions. But collisions do happen, and they happen a lot. And what we provided that situation is total recall of a scenario of a collision. Okay? In case of a collision, we create a report for the driver, for his insurance company, okay? Totally understanding what happened, reconstructing it, understanding who's to blame, what the forces are, preventing fraud. We can even do that in 3D if you really insist, like in this case. And more than that, we actually validated it in the real world. You can see in this video, we have a startup that allows us to crash cars. You know how fun it is to go out, actually get a license to crash cars? What you see here is a series of experiments that we've done in the last year in order to really validate our algorithms against the scientific, really expensive setup to make sure that our predictions, our sensor fusion, our calibration is all intact. And this is the kind of thing that you can do. You can really go millisecond by millisecond and understand a situation like that. And that's great because that allows insurance companies to move from risk analysis to really understanding a situation. It allows claim adjusters to move much faster. It allows us to provide a service where today, within 5 minutes, someone is on the phone helping you. And it allows them to provide discounts to their customers, up to $500 discounts on their insurance. In general, it allows sort of a move from an interaction with the insurance company where you meet them once a year, typically in a negotiation scenario, to a place where they can actually trust you and you trust them, and there's an ongoing relationship. Yeah? What we can do also is understand the driver, profile the driver. Every second we can measure your tailgating, we can measure how many times you move lanes, what is your velocity relative to others, and understand your profile, and even more than that, help coach you, help train you to become a better driver. Really dealing with the problems that create collisions today. Now, there is a second order effect. People have talked about data. This is the Nexar network and how we see it live. Okay? This is a sliver of our network in New York. We capture all of this data, and then the next immediate step is to run that through our AI models. right? Understanding every traffic light, understanding every traffic sign, understanding how the road changes, cones on the road for construction, all of that in a live manner. If you look over time, what you see here is a new model for an air traffic control for the road. Okay? A way where we understand how the city evolves, how the transportation in the city evolves, what are the issues, what are the problems. You mentioned Las Vegas. This is one of the cities that we are working with, and we discovered there that there are specific intersections where there are lots of hard brakes and hard accelerations. These are not in the strip, right? Not in the main road. So we went to our partners there and asked them, what's going on there? And they looked at this and were like, of course, these are the pedestrian exits from the casinos. People are coming out, going in, all the cars kind of going, these are side roads, and start to, swivel between the cars. These are the kind of things that all of this kind of data allows you to do. Now, looking into the future, with my closing remarks, say, what we envision is a world where there are millions of these cameras, running around the roads, allowing us to predict through this network every collision and prevent it. You can see millions of vehicles driving harmoniously in tandem, okay? Because if you think of all of the friction that exists today, if you think of congestion, the reason for that is because each one to its own, right? Think of an internet where every packet will decide on its own where it wants to go, okay? That's what you're going to get. You get the kind of congestion that we see and suffer from on the road every day. And most importantly, we can imagine a safe and secure environment, a safe and secure public space. And we strongly believe that we can achieve all of this in the next few years. We've already got to a point where we have tens of thousands, hundreds of thousands of these cameras and these nodes in our network all over the world. And we think that we can take it to the next level together with many of our partners in the insurance industry and many of our partners in the OEMs to get to a point where this network actually predicts and prevents as many collisions as possible. And with that, thank you for your help. Thanks, sir.